I'm really glad to see so many of you coming back after the short break. I know the air conditioning here is not good for the last sessions to stay awake, but still, I hope we'll make you awaken for some time. Anyway, my name is Mateusz Chromiński.
My name is Krystian Panek.
We're both coming from Cognifide, and we'd like to guide you through the journey of lazy developers. So before we start considering how to improve the developer experience, let's try to first define that term. It may be pretty new to you. So decomposing that two words, developer, I think it's the easy one, but experience is really catchy term nowadays. So brands speak a lot, our customers speak a lot about experiences. This is something that they understand in their own language, of course, but still, this is something that generates the actual revenue for them. So experience nowadays is extremely important because new generation of employees are coming to the market, especially in IT. They are actually thinking in a more emotional way. So whenever experiencing with a tool, a process, basically anything, the younger the developer is, the more likely he is to think more in an emotional way rather than using some objective arguments. So working within the web development, we were most likely exposed to the term of user experience. So the set of emotions and reactions that the end user, visitor, site visitor, feels while interacting with the website. But actually, Sling is a base for one of the largest CMS solutions. So some of you may have heard about the term author experience. So the actual experience that the corporate users are feeling, emotioning, while working with the authoring environment. So what we sometimes do not actually understand is that providing a good tools for authors actually very immediately translate to a better user experiences because they are creating the user experiences. It's not us developers who are directly building it, we are just giving them tools to build that. So while some of us think about authoring experience, most of us think about user experience, do we consider ourselves, so developers, being in the same pipeline? So the better the developer experience is, the more integrated it is, the more delightful it is to use, the better authoring experiences we will be creating, and the better user experiences, in fact, will be created. So what does it mean to have a good developer experience? What are the factors that drive good experience? I believe that there are three main factors to be considered here. So definitely the tool, the solution needs to be usable. I mean, it needs to be functional already. If it does not contain enough features inside, I mean, not too many, not too few, just the expected number of them, and they are just working well without too many errors, that's just prerequisite to use it. But it not only needs to be functional ready, it also needs to be simple to acquire, easy to acquire. If the learning curve takes months to master, I'm sure that many of us will just leave that tool apart and just move on. And then finally, I think the most overlooked factor is actually the enjoy that we find using the tools. So if the tool is not fitting nicely within the technology stack of ours, if it's just not creating enough fun for us, developers, big kids, right? So the toys need to play with each other. So if it's not in place, again, that's not creating a better developer experience. And finally, if you start thinking about our experiences compared to the other industries, to the other sectors of basically world, so whenever there's a change in a factory, like the change introduced to have assembly lines in place, consider that in the same triangle. So that change was definitely very usable. I mean, it provided very operational ready change to improve the pipeline of development in that area. It was pretty simple to acquire. I mean, learning how to work on that pipeline, I'm sure it shouldn't take more than just a day. But finally, was it delightful? I mean, I've been working in similar place during my studies, and I can tell you that this isn't at all enjoyable.
Let's think about the developer experience in case of Sling-based applications. The well-known software engineering model called software development lifecycle, it could be perfectly used to indicate particular stages in the projects. And I reckon that it consists of requirement analysis, design, development, testing, and maintenance phases. And I reckon that the developers, I mean the regular developers, are mostly involved into the last 3 stages. I'm not thinking about the architects and technical leads, the regular developers. And during that presentations, we'd like to focus on that, the last 3 stages, and try to find some smaller, some bigger improvements that could help achieve better developer experience and just make developers more happy and more effective at work. As a developer, what I need to start working on the projects. Of course, I need some environment to work, best if it will be my own local environment. In case of Sling, I need Sling instance. In case of Adobe Experience Manager, I need an author instance and publish instance. Sometimes even more software to be installed. For instance, Apache web server with dispatcher module installed, some Solar search engine, some database systems, and so on. Okay, let's assume that I have already defined an environment and it is working right now. What next I need to start working on the project from developer's perspective? Of course, I need some code base, I need some code. Usually, I will generate that code from project archetype, from Maven archetype. Sometimes I will even copy existing project and adapt it to future needs, and by just repackaging the classes, correcting the Sling version, AM version, compile dependencies, and so on. Now let's imagine that I already done it and save that code in the code repository under version control system. And what else I need to start work? Of course, now each developer, each other team member could clone the repository and start writing the code. But while writing the code, we need, of course, the tool that will build that application and deploy it to Sling instance, to AM instances, and so on. And usually it is a Maven. Okay, let's assume that we have our application, we have everything needed to write the code, and what's now? How I will test the application that I'm creating? In that stage, we have a variety of testing methodologies. In case of small projects, the manual test will be good enough, in my opinion. Especially if we have only few team members, that will be good enough. But if we are writing some code which is unsafe for us, we are writing some code, low-level Java code, some code performing math calculation, we could protect ourselves by writing unit tests. But what if we have not enough power to perform manual tests at scale for bigger count of pages, and so on? We could automate that manual tests by implementing functional tests, for instance, in Selenium, Protractor, that kind of technologies. And what if even user experience is very important while we are developing applications? What if the page rendered on the browser is mostly important from our project manager perspective, let's say? In that case, we could use automated regression testing that will compare the page before the code change, after the code change, by comparing the screenshots, for example. Okay, let's assume that I'm after the application build phase, my application is tested perfectly, and now I'm after the go-live day. I'm very exhausted. I went home, went sleep, and next thing morning, some guy from DevOps team is calling to me. Hey, Krystian, something is not working correctly. There are errors in logs, and you need to fix it. Of course, in ASAP mode, and then I need to just be good at troubleshooting. From developer perspective, in my opinion, it is mostly important. I need to be good at finding the bug root cause. I need to be, then I could even, not always, but I could reproduce the problem on local environment. Then I could fix the problem, run all tests, deploy application to the production once again. So as you can see, the developers are heavily used during all three, especially in all the three stages of the project. I mean, in development, testing, and maintenance phases. And we'd like to show you some examples for improving that developer experience in that stages. Let's start our journey. In case of environment setup, how dreamt environment could look like. In my opinion, the best if we will just get our environment very quickly. Best if that environment will work as fast as is possible. So that's very important, especially in case if we know that problem. The companies are having usually diversity of unique developer skills. The companies, let's say, during project development, in early stage, it is needed. Somebody needs to configure Solar search engine, and the project needs developer A, but later, some other developer, B, let's say, is needed because it's better at implementing components, so that developers are migrating from one project to another, and they both need to set up their own local environment, let's say, or some environment. So that wasting that time, wasting that resources is not so good. It could be expensive. We are expecting that developer will start working fast and effectively. Okay, another thing. In my opinion, all the environment need to be reproducible because developers are very natural to the experiments. The developers are integrating features never integrated before. So sometimes they will damage environment and need to have it restored to the previous working state. So that's also important to make the developers to have work more freely without stress. Okay. So close to that dreamt environment is, in our opinion, it's our proposal to use Gradle-AM plugin. It's a Cognifide's battle-tested solution within the last 3 years. And now it is our standard for building AM applications. And sometimes it is also used for setting up local AM instances. What could be interesting, that solution is cross-platform. It could be running on Windows, on Mac OS X, on any Unix. And it is creating local AM instances without using any virtualization. So we have here native AM performance. What could be also very, very good from developer's perspective is that it only needs to have a Java installed on the machine, so that any UI developer, QA developer needs to only have Java installed, and all of them could run single command to get fully automated environment. You may be probably curious how it is working in the practice. May I show you? I just cloned the repository, the example multi-module project from our GitHub, and we will just roll out in a fully automated manner local author instance, local publish instance. We will deploy dependent packages and deploy our application and so on. You are probably new to Gradle, so that may I explain you some details. In Gradle we have a task instead of goals. In our example, we are running a AM setup task, which depends on other tasks. In our case, it is a AM resolve tasks, AM create, AM up, AM satisfy, AM deploy, and AM await. And we are just running AM resolve task, which is downloading AM jar from remote source, in our case, from a remote server using HTTP protocol. Then we have collected license file. Now we are collecting the dependency CRX packages required by our application. And later, we will move on to the next step. We are just creating the local AM instances in an automated way. We are even opening the debugging ports for developer. We are even notified about the fact that AM instances are ready to be launched. Okay, now we just created 2 instances, local author and local publish in our case. But we could even configure more by just adding single line to Gradle properties. Then we could run the instances. Right now we have about 25% of stable OSGI bundles. We are being notified about that instantly, and we just made the fast forward for the better demo experience. And now we will move on to the next step of the AM setup, let's say procedure, to the AM satisfy task. And by launching AM satisfy task, we will deploy previously downloaded packages, and then after each installation, we will check for the condition of our AM instances, so that process of installing dependency CRX packages is very, very stable. Okay, we are right now installing the Kotlin OSGI bundle, because it is required by application. We could even write the application using Kotlin language. Our application could depend on ACS AM commands. So we are installing We are installing it right now. The next step after installing dependent CRX packages will be the AM deploy task. AM deploy task will simply deploy so that upload the package, then install it on instance. And what could be interesting, the application was built in the initial stage of running the AM setup command, because the Gradle is using directed acyclic graph to determine which things could be done as early as this is possible, so that we just build application and then we could reuse previously built package and deploy it in correct moment. As you can see, I created the fully configured, in a fully automated manner, our AM environments. That's the empirical result of running that command. And we have dependent packages installed. You have some migration tool like Groovy Console. We have some developer tool like Felix Web Console plugin called Search, and we have our application named Example. All in fully automated manner, being within 12 minutes on desktop PC, without recording enabled, because I have recorded the demo. You could achieve even 7 minutes that fully configured environment within 7 minutes. But what alternatives do we have currently in case of environment setup? We have a virtualized environments, but some of you could ask me, is the Gradle AM plugin configuring only the AM instances? And the answer is yes, it is only configuring the AM instances. If you need to have more software installed on your machines, you could mix the Gradle AM plugin with your virtualized approaches, which are using Puppet, Chef, Ansible, and so on for provisioning and so on. Okay, let's move on to another activity in our development stage of the project. What are expectations in case of application build? In case of application build, in my opinion, it must be as quick as is possible. It is very important. I can tell you why. As a developer, I'm very, very often losing the focus. It is because the maven-based builds could take much time, especially when the project is becoming bigger and bigger. So that if we had such situation, the developer is not working efficiently. The developer is forgetting about what he just changed and what he needs to test right now. So it is very, very important. And what if, another thing, what if the application will be application build will be a little more intelligent? What I mean in that case, I mean the deployment of CRX packages is not so trivial in case of Sling-based, OSGI-based applications. It is hard to determine when the application is ready for tests. And because the bundles are not getting active immediately, the OSGI is not so deterministic. So if the build tool will inform that in some way that the build ended and we could just start testing in the exact moment, we will have more time for even reading the web or any other important things that we need to do. Okay. To address that problem, especially in case the performance of the build, our proposal is to use Gradle AM plugin. The Gradle AM plugin is, of course, based on Gradle, and Gradle fundamental concepts are the incremental build and extended parallel processing. So that because of that fundamentals, the build could be even at least 2 times faster than Maven-based. And our observation is that the bigger project is, the more boost we could observe. Okay, what if the build tool will inform us about the moment when the application is ready for tests? And the Gradle AM plugin is doing that. It is displaying the nice notification that some bundles are not active, so that we are immediately know that something is wrong with our application. That is a drastic change when comparing the build to Maven-based. Also, developers want to be self-sufficient. What does it mean? The developers are very often have also good Unix skills. They are able to configure a web server and so on. And applications are very related to the environment. So that if the environment-specific details will be also configurable in one place in code repository, the developers could even not require to engage the software engineers. They will just do it by their own. And what is worth to indicate, the Gradle AM plugin is very, very configurable and flexible. So it be used exclusively to only build applications and for only setting up local AM environments, or even to mix that approaches. It's all upon your needs. And may I show you the only application build? Imagine that I just changed a single line of code in Java source, and now I'm just running the most simple command, which is just Gradle W. What does it mean? I just use the default task features, which by the default task features, which means that I just run the pre-configured task. In our case, it says aim satisfy, aim deploy, and aim await. And what just happened? Comparing to the Maven build, in Maven we just are uploading the package and then installing into instance. But here we just done a lot of more things. We checked that some other dev probably configured some extra dependent package, like hotfix for Adobe Experience Manager and or even some other CRX package needed. And Gradle will check that if that package is already installed. If not, it will install it automatically. So that change will arrive to our environment in a transparently. And what is more, the Gradle is very incremental. We just rebuild application, and Gradle noticed that the SCSS file haven't changed, so that node was not running. Generally it is time-consuming, so that because of the Gradle change detection, it was so fast. Maybe you are not impressed about 19 seconds, but I just ran that on the notebook with recording enabled. It's a multi-module project. It is very complex, but it on a more quick machine, it could take even 6 or 7 seconds, really. When you want to just compare the build, which will do exactly the same, which will do just upload and install as in Maven, which is also possible in the same project, we could use Gradle and Maven in the same build. We could have dual build configured. You will notice that the Gradle, by using same configuration, the Gradle will be faster than Maven at least 2 times. So it is very nice. But what if the developer has another perspective? The build time is not only important. Very often developers want to have nice IDE integration, so that good old Maven will be good enough. So that, especially when it will be used within Eclipse and Sling IDE tooling. We cannot forget that the Gradle, but that the Adobe Experience Manager is based on Sling, and also the Sling is currently being distributed as a self-extractable jar, like IAM. Also, the Sling starter consists of composant package manager, so that because of that concept compatibility, where the Gradle Sling plugin could born and become available. It is working so nice, so may I show you? I'd like to perform a demo, but similar to the first one, but with 2 exceptions. First of all, we will add extra step. We will create the project from the kinda archetype. I'm telling kinda because it's not exactly archetype like mechanism, because we are copying the example project and some existing project and adapting to another one in an interactive way. Then we will roll out the Sling instance and deploy dependent packages and deploy application, all in a fully automated manner. May I show you how it works? So that I'm just cloning the example project from our GitHub. Then I will adapt to be new one. I will repackage the classes. I will give it new name. I will replace all code occurrences of example. I will change it to sample. I'm generating the project to sample directory. They I'm giving. They are assigning new Java packages, base Java package, and then I'm giving that new name of the project. And then right now I'm changing directory to that project, and now I'm generating a user-specific configuration in an interactive way. I just customized the HTTP port on which Sling will be launched, for instance. And now I'm running Sling setup tasks, which is similar to the AM setup. Right now we are downloading Sling Starter in version 11. Snapshot. The snapshot is here because we needed to add some endpoints to the Composer package manager. What could be interesting is that changes are already approved, and that endpoints will become available in the next official Sling Starter version, so that we could, within some time, we could use the stable and official Sling Starter version. Right now, we are using the Sling Starter build from Snapshot and stored on the GitHub. Okay. Right now, we are running Sling resolve task. We are collecting the dependent CRX packages. And right now, we are installing it. I'm sorry, right now, we are booting up the Sling. We will have a little difference here because the Composer package manager is booting a little more time, and Gradle Sling plugin will detect such situation. As you can see, we are making some delay, and we will check the Sling conditions once again within some time. Okay, now it's up. Our Sling is running correctly, so we are able to deploy CRX packages, Vault package to the Sling instance. What could be interesting, the Sling Satisfy could even transform the SGI bundle to the Vault package on the fly. That's another feature of Gradle Sling plugin. And okay, within about 3 minutes, we created a completely new project and deployed it on fresh environment and deployed our application with dependencies. So this is very, very nice from developer perspective. And what is also worth to say, developer could even run Sling resetup task and destroy the currently running Sling instance and then create it again and deploy application again. It is fully automated, very comfortable to work.
One, two, three. Yeah, I'm back. OK, so you have seen how fast it could be to create a new environment and how convenient it could be to implement a new change and push it to the environment. And consider that being given a production environment within the continuous delivery mindset. So having an ability to push changes so quickly seems very tempting, but it also creates a kind of a great responsibility on our shoulders. So as Superman says, with great power comes great responsibility. So we need to be shielded against all the changes that are being applied by accident. So what was introduced with the code that we expected should not actually bring any other changes. There are other tests, like Krystian mentioned, that can help us. Also, we do some manual testing, of course, so opening the AEM or Sling instance and seeing if it's just not broken completely. If it's broken completely, that's pretty easy to find out. If there are well-automated tests to find out the actual thing that we've been working on, is also good. But I mean, within AEM environment, it can become really complex to find out changes that are being hidden somewhere deep in the, let's say, footer of the page, where you will find some legal disclaimers that may not be so easy to find out. But they have great influence on our brands, on our customers. So having an ability to change the regression quickly without too much human effort is something really important and worth to introduce to the process. So within Cognifide, we are using a tool called AT, which is a scalable solution that helps us monitoring all the websites, but not monitoring from the health point of view, so whether it responds, whether the performance is right, and so on, but rather from the regression approach. So we do collect all the patterns, so-called baselines, for the websites, for all the pages within. The baseline can be either a screenshot, source code, a list of expected JavaScript issues, or HTTP codes, or whatever you'd like, because that's a fully open solution where you can introduce new collectors as well. And then using a scalable approach, so you can add new nodes as you go, improving the performance of overall test. You can just collect the current state of your website and then compare it back to the baselines that you expect. So let's have a look into a short demonstration. Oops. Here we go. So on that Sling instance, there is installed a very simple application coming from examples, so Slingshot. And on the AET environment, we've got set up 3 pages. So there's a login page and 2 pages, including the gallery. That is the idea of Slingshot. So we do have collected some patterns. So in this case, there are screenshots. You can see that there is also an ability to switch to the source code. You can review them and so on. Let's imagine that our task is to introduce some border around image in the gallery. Let's jump into the CSS code. Let's add just simple line of code. I'm not great UI, so I'm completely not a UI, so that will not be appealing at all. Nevertheless, after the installation, here with the Maven typical build package, but seeing how Krystian introduced Gradle AM, Gradle Sling plugin, that could be done this way as well. After just a couple of seconds, we'll see that live and deployed. So we will be able to then collect what are the actuals of our websites. So switching the tabs right now, running just a simple shell command. This can be, again, introduced within the Maven plugin. It can be integrated with Jenkins pipeline. We've got 3 pages being tested. Let's refresh the AET, and we'll now see 2 red reports. So 2 changes have been found on the Slingshot application after doing just such a simple change in the CSS file. One of it is the one that we were expecting to have. So there are some borders, not so nice, but you open your imagination, that are being applied to the gallery. We wanted that change, so we accepted that these are our new patterns. But there's also another change appearing in the other page, appearing on the other page, which we did not expect to have. And that is an unexpected change that should get back us to the development lifecycle, so we are able to fix the bug and just do it correctly. There are other tools on the market. Some of them are open source, some of them are software as a service, some of them are, most of them are actually treating only screenshots comparison. In our case, AET is something that you can host on your own, that you can host on your internal infrastructure. So considering GDPR and all the banking customers, it may be tricky to actually start sending screenshots of the site that is being built to some external environment. So you can have it on your own within your ecosystem, within your DMZ, and just configure it as you go. You can even start implementing changes that are more compatible with your lifecycle of projects.
Personally, when I think about the maintenance phase of projects, I'm seeing the diagram illustrating the server load, or error count in the logs. So that I think that the developer is mostly involved into troubleshooting, and good troubleshooting methods could just save our money, save our time. And to perform good troubleshooting, the developer should easily find the bug root cause. When he finds the bug root cause, then probably he could reproduce the problem. In case of OSGI, it is not so trivial to be sure that the code is correctly deployed, the class is the class that we expect is on the runtime used. It is just not trivial. The bundles, the Sling installer could have a pause installation. That edge case situations may come. so that to address that problems, to be good at troubleshooting, the OSGI developer could use Search Web Console plugin for Apache Felix. By simply deploying single jar on the instance on any time, even on production, the developer will achieve immediate way to discover runtime, to preview actual versions of the class of Java classes. By using the compile and search feature, developer will even achieve the very easy-to-use method for finding the class which is causing a problem. When we are searching for the message that comes from log entries, we could use some kind of search mechanism to indicate the class which is causing a problem. Also, developer could use assemble OSGI bundles feature, which will allow developer to download bundles from a running instance, to be able to pin them to a favorite IDE, to be able to start debugging any code that comes from running platform, coming from instances. May I show you how that plugin works in practice? After deploying that plugin, we have a new option under OSGI menu. It is called Search. And now imagine that I know to know more details about the resource resolver currently deployed on OSGI. It is very easy. I just search for it, and now I'm clicking the bulb icon, and now I will see the actual version of class used on instance, so that it is the compilation feature that could give us some powers to be able to discover any classes, to discover how to integrate our code with any other platform code. We could jump over from one class to another by simply clicking it, as you can see. Okay, the next feature of a Felix Search plugin is decompile and search. May I show you? Now I'm just filtering I'm looking for all bundles related with resource resolver. And now I'm just want to know anything that these bundles are connected with session. How are they connected? As you can see, it is very simple. I just writing a session in that dialog, and I see the context where the keyword is located. So it is very, very powerful to discover runtime. And probably we could look for the message coming from error logs. As you can see, I'm just copying it, and then I'm able to just paste it, and then the code which is causing a problem is being found, so that we could analyze the code and be able to reproduce it on other environments because of performing static code analysis. Now I'm just showing you another feature. We are just decompiling all classes from selected bundles and then getting it as a zip file. And now we are just assembling the bundles, so that I'm just collecting all bundles deployed on OSGI to be able to extract them on my file system, then pin them to, let's say, Eclipse to IntelliJ, and be able to attach breakpoints and to preview the memory and be able to analyze the problem more deeply. But what if the static code analysis is not good enough? We have performance issues, for instance. Then the profilers are coming with the help. And what the profiler you will select, you will choose, is all upon your needs.
So you have seen just 3 simple improvements, actually 4. And we can imagine that this wasn't a demo that would help you configure it on your own. So if you are interested in using these tools in action, we invite you to join the GitHub channel, where we will be helping you to do that after the adaptTo conference. And finally, a simple line from my side. So all berries are edible. That isn't actually true, because there are some wild berries that can make you really sick, or even you can die because of them. But nevertheless, you will always be choosing the berries that will fit nicely into your cake. So we can imagine that these tools maybe interesting for some of you, but within the other projects, within the different kind of projects, probably there are other options, just like Krystian mentioned, virtualization. If that's coming in place, you shouldn't actually think about having a native AM performance. We don't have much time for the questions, I believe, but...
2 minutes. It's fine. If there are questions...
There's one.
One question about the Gradle plugin. Can you install a dispatcher with it?
Could you repeat once again?
So can you also install a dispatcher instance?
No, because the installing dispatcher depends on the operating system that you are using. So it is hard to do it without re-virtualization.
Oh, okay. And can you install service packs?
Yes, of course. It was tested within even 500 megabytes of the package with that size. It is working very, very good. It has retries mechanism for uploads, for installs, so that it is very, very it is very protected against errors.
Thank you.
Yeah, so very nice presentation. Thank you. Here. Can you give an approximation of time it would take to analyze and render, let's say, an AM page that has, I don't know, stage and a teaser gallery and a few other components, like in time?
I mean, it depends on your AM performance, because AT works just as an end-user browser. It uses Selenium under the hood, so it basically mimics the typical user behaviors. Okay. That actual logic in AT takes really quick time.
Okay, thank you.
Any further questions? There's one in the very back on the left-hand side.
When you say it mimics Selenium internally, what kind of browsers or what kind of support does it currently have? Because last time I've checked, it was an ancient version of Firefox, wasn't it?
Yep. That was a long-time support version of Firefox, but recently we moved to Selenium Grid. So basically, it's now open for any browser. We will be using Chrome. I mean, it's already available, so you can use Chrome very easily.
Okay, any further questions?
Thank you very much.
Thank you.
Yeah.